Hello, this is Ken Popkin, and I'm presenting the Project 3 results for the KJW team, which is Jagdish Chabria, Willie Smalls, and myself. So what we'd like to do is share with you today our results from, as you can see here in the About This project, we were trying or tasked to create the best name gender classifier that we possibly can while using either decision trees, naive Bayes, and or maximum entropy. And for this assignment, we chose to go with naive Bayes. So as you can see, coming down here to the data set, we were asked to use the names corpus from the NLTK module in Python. So we loaded that up, brought in our naive Bayes classifier. Loading the names was pretty straightforward. Went into a data frame without any issues. And from there, we decided to do a few high-level metrics on the data. As you can see, there were 2,943 male names, 5,001 female names, for a total of 7,944. So the data set is skewed towards female names by not quite 2 to 1. And another interesting finding is that there are 365 duplicate names. So we made the decision to remove those names so that we would only be dealing with a binomial classification of male and female and not names that would be assigned to both. Coming into features, there wasn't a lot to work with when you get a data set that only has names, but with the features that we came up with is we could try the last letter of the name, first letter of the name, the length of the name, and if the name has repeating letters in it or not. So with those 4 features in mind, we moved forward with enhancing our data frame, as you can see here, to have each of those. Pretty obvious for Megan, last letter of N, first letter of M, length of 5, and no repeating letters in her name. Valida, however, does have the letter A that repeats, so it has a 1 in this field. Coming down now to the more interesting part of every data science project where we actually run our model. What we did is we created functions for each of the features that we just mentioned above. And then coming into this section, we chose to employ bootstrapping so that we would definitely have a very randomized sample as we compared our results across running naive Bayes through each of these combinations. So as you can see here, with the shuffle step right here, the for loop running 100 times, and each of the feature combinations that we talked about, starting with last letter, coming down here and ending with first and last letter features, and then an all feature set. What were our results? Our results were that the all features accuracy consistently edged out the others, not by much though. In terms of first and last feature only, at 80%. Last letter accuracy is 79%. So it's very obvious that last letter is the most significant predicting feature of the all features data set. But nonetheless, going with the best model, which was the all features data set, we moved down here into our test data, which was the last 500 rows of our data set. And when we ran that, we ended up with an 82% prediction. So coming into the conclusion, how does the performance on the test set compare to the performance on the dev test set? Stating the obvious from what you saw already, with a result of 81% on the dev test data, 82% on the test data. They're obviously very close. And is that what you would expect? I would say yes, it definitely is, seeing how our data set is only a list of names. And we had already done pretty extensive bootstrapping exercise on the dev test data. So it makes sense that the test data would come in reasonably close. Wrapping up with this footnote, I found the link to this site. It's a GitHub library, and it had some very good information that really helped me get oriented to how to use naive Bayes in the NLTK library. Thank you for your time today.